All right, so now we're going to do some example problems of turning verbal expressions into math sentences and math sentences into verbal expressions. One of the biggest things to remember is the more than, less than rule. Think about Sandlot. You can't have some more of something if you haven't had something to begin with. So anytime you say more than or less than, you have to put it after, move it to the end, because you have to have something to start with to have more than that or less than that. So, for our examples, it says write a verbal expression for the following algebraic expression. I have 3x with a little 4. So there's a couple different ways that you could write that. Your answer may be different than someone else's and yours could still be correct. This 3x next to each other shows that there's some multiplication going on. The power of 4 means that I'm multiplying that x times itself 4 times. The way that we could just say that is 3 times x to the 4th power. Just write it out just as that sounds. 3 times x to the 4th power. You could also use some fancier math words and say the product of 3 and x to the 4th power. Remember, since I said product, that meant to multiply, and I used the word and to put that in place. So the product of 3 and x to the 4th power. Coming here, I have something with a variable and a constant term. So I have this 5n squared. That's going to be 5 times n squared and plus 16. You could use just those terms, 5 times n squared plus 16. Remembering that squared is a special term for the power of 2. Or you could have said 5 times n to the power of 2 plus 16. Or you could say the sum of 5 times n squared and 16. Any of those would be acceptable answers. Once again, we had our reminder, Sandlot, when something is more than or less than, you have to move that number to the end of the expression. Lastly, we're going to take the verbal expressions and turn them into algebraic expressions using those numbers, creating a number sentence. The number t more than 6. If you remember earlier, we talked about the letter T is a dangerous letter, so when you write it, you want to make sure that you write it in a scripted form. So you want to make sure that T has a tail, so it's not misinterpreted as an addition sign. So a number T more than 6. So T more than means I'm going to add T, and I need to make sure that I put that at the end of that sentence, so it's going to be 6 plus T. The product of 5 and x, product tells me to multiply, and tells me where I'm going to put it. So I'm going to multiply 5 times x. So there's a number of ways that you can represent that. I'm just going to write that as 5x with nothing in between because that represents multiplication. You could have also used the raised dot, 5 times x. You could also use parentheses, 5 parentheses x. All of those are acceptable ways to represent the product of 5 and x. Then I have 10 less than the product of 7 and f. It's kind of a combination of those two. 10 less than means I'm going to be subtracting 10, but I've got to move it to the end of my expression. And then the product tells me that I'm going to be multiplying. So to show my work, above product I show that little times sign. I know that I'm going to put that where the and is. So 7 times f, I'm just going to represent as 7f. 10 less than that means at the end I'm going to subtract away 10. So 7f minus 10. The quotient of 54 and p, quotient means to divide. In algebra, we no longer use this symbol for division. Instead, we use a fraction bar. So 54 will be my numerator, and p will be my denominator, and it's just represented as 54 over p. Those are some of your basics. We have one more example. 2/3 of the volume V. 2/3 is going to be represented as a fraction, 2/3. 2/3. Of means we're going to multiply, and we're going to multiply times the volume, which they've asked us to represent using the variable V. So just 2/3 V. Homework, page 7, numbers 1 through 30, and page 43, and page 9, number 43 through 46.